Radiation can be defined as the energy carried in the environment. This energy is carried through particles and electromagnetic waves, energy packets without mass called photons. An atom is an atom. If the energy carried causes ionization in atoms, it is called ionizing radiation. Alpha particle, beta particle and neutron particle radiation, gamma ray and X-rays are examples of electromagnetic radiation, and they are all ionizing radiation. If radiation, carried energy, does not cause ionization in atoms, it is called non-ionizing radiation. The energy carried by this radiation does not cause ionization, as it is not enough to pluck electrons from the atom. All types of non-ionizing radiation are electromagnetic radiation. Radio waves, microwaves, and visible light used in communication are examples of non-ionizing electromagnetic radiation. Radioactivity is an event in which atomic nuclei with excess energy release their excess energy by releasing radiation. This event is also called radioactive decay. The decay event of a radioactive nucleus is a probability-dependent process, and the probability of decay over a certain period of time can be calculated, but it cannot be determined exactly when the decay will occur. The radiation emitted by radioactive atoms per unit of time is called activity. The amount of time it takes for the initial activity of a radioactive substance, or in other words, the number of atoms, to be halved, is called half-life. Half-life is very important as it is a parameter related to decreased activity. Types of ionizing radiation. Ionizing radiation is grouped into alpha radiation, beta radiation, gamma radiation, neutron radiation, and X-ray radiation. X-ray emission mechanism. Alpha radiation is a helium atom nucleus consisting of 2 protons and 2 neutrons. Its mass is greater than other types of radiation and has 2 electric charges due to protons. Alpha decay appears in atomic nuclei with a large atomic number, and the number of protons and neutrons of a radioactive nucleus that performs alpha decay decreases by 2. Because alpha radiation is heavy and has a load value of 2, it performs Coulomb interactions in the medium it enters, causing ionization and losing its energy very quickly. Therefore, the penetration power of alpha radiation within the medium in which it interacts is very weak. A piece of paper or human skin is enough to stop alpha radiation. Beta radiation is usually an electron with a minus, or rarely a plus, charge. In fact, when an electron is called, it is first understood as a minus-charged particle, which is also called a negatron. The plus-charged one is called a positron. Positron radiation has a charge of +1, 1, electron radiation -1, -1. Therefore, beta radiation interacts with Coulomb in the environment, causing ionization and losing its energy.